Okay, this section brings us to section 6.2, trigonometry of right triangles, which is hopefully something that you have seen before in geometry. What we're going to be talking about now is sine, cosine, and tangent, cosecant, secant, and cotangent, just like we did before, but we're going to be talking about it in looking at it as a right triangle, and more as a right triangle and less on the unit circle. Now remember, these right triangles always can fit on the unit circle, and you use them on the unit circle, but we're going to pay more attention to these right triangles in themselves in this section. Hopefully you remember the old acronym SOHCAHTOA, SOHCAHTOA. Sine is opposite over hypotenuse. So if you have your angle theta here, the sine of the angle theta is the opposite over the hypotenuse. So SOH. Cosine is adjacent, cosine of angle theta is adjacent over hypotenuse, CAH. And tangent is opposite over adjacent, TOA. And then of course cosecant, secant, and cotangent are the reciprocals of those angles. So we're going to use those trig ratios to actually solve some problems. Okay, so for example, if we're asked to find the 6 trig ratios of the angle theta in this particular problem right here, what we need to do is first figure out what the sides of the 3 angles are. Do you see that we have 2 of the 3 sides? Whenever you have a right triangle, you can always use the Pythagorean theorem, a squared plus b squared equals c squared. And do you see that we could say 7 squared plus b squared equals 8 squared? Again, remember c squared always has to be the hypotenuse of your right triangle, which in this case would be the length 8. That's the hypotenuse. So, if we're going to solve, we would subtract 7 squared. We get b squared equals, b squared here is going to be 64 minus 49, so b squared equals 15. So b is going to be plus or minus root 15, which has to be positive because it's a unit of length. So let's plug in square root 15 right here, and we're going to find our 6 trig ratios. Okay, sine, remember, is opposite over hypotenuse. This is our theta right here. Since our theta is up here, the opposite is going to be 7, the hypotenuse is going to be 8. So our sine is 7/8. Cosine of this angle theta is going to be adjacent over hypotenuse, or root 15 over 8. Tangent of this angle theta is going to be opposite over adjacent, 7 over root 15, which rationalized would be 7 root 15 over 15. Now, to find the reciprocal identities, we just take the reciprocals of these 3 values. 8/7, 8 over root 15, which would be 8 root 15 over 15. And then the reciprocal of 7 over 15 over root 15 is root 15 over 7. So those are the 6 trig ratios of that angle theta. Okay, so let's try another problem. If we know that sine theta, or sine alpha, this little fish sign is actually a lowercase alpha, and we always use Greek symbols when we're referring to angles. If sine alpha is 4/7, we want to come up with a right triangle here. So let's go ahead and draw a right triangle and plug in what we know. Okay, let's just say alpha is that angle. We don't know what it is, but we can pick one. If the sine of alpha is 4/7, wouldn't you say that the sine of alpha is 4/7 means opposite of alpha is going to be 4 and hypotenuse is going to be 7? So to figure out the other side of the triangle, we're going to have to use the Pythagorean theorem. 4 squared plus b squared equals 7 squared. So 16 plus b squared equals 49. So b squared equals 33. Take the square root of both sides, so b equals root 33. So now that we know that this side is root 33, we could find all 6 trig functions of alpha, never even knowing what the angle alpha actually is. We just need the side lengths to find the actual angle. Okay, so the next problem is asking us just to find the side labeled x in this triangle right here. So to find the side labeled x, what we need to do is look at this angle, or look at this triangle, and see what we know. We know that one of the angles is a 45-degree angle, and we also know one side. Since we don't know two sides, we can't use a Pythagorean theorem. We have too many unknowns. But we do know that this angle is a 45-degree angle, and we're lucky because that 45-degree angle is a special triangle. And here are the special triangles. There's a little cheat sheet in case you have forgotten. So we can easily figure out, since we know that this is a 45-degree angle, we know 12, we know the opposite, we don't know the hypotenuse. Do you see how we could set up a trig ratio? We could say sine 45 equals opposite, which is 12, over hypotenuse, which is x. And because the sine of 45 is a special triangle, can we figure out what the sine of 45 degrees is? That's the y value at 45 degrees on the unit circle, or you can look at your special triangle. Do you see 45 degree is opposite over hypotenuse, and the opposite of 45 degrees is root 2 over 2. So we can replace sine 45 is root 2 over 2 equals 12 over x. And now do you see that we have an equation with one unknown? We can cross multiply here, and we get x root 2 equals 24. Divide both sides by root 2. We get x equals 24 over root 2. If we rationalize, we get x equals 24 root 2 over 2, which is 12 root 2. That would be that side length. Okay, so let's do a couple more to get a little bit more practice here. Let's look at this triangle. We know that this is 30 degrees. We know that this is a side length is 4, and we're looking for this side length. So do you see that this is opposite and adjacent? So if we set up a trig ratio, the opposite over adjacent trig ratio is tangent. If we set up tangent 30 equals 4 over x, can we use our special triangles again? If we go back to our special triangles, tangent of 30 degrees. Let's go to the 30-degree special triangle. The tangent of 30 degrees is opposite over adjacent, so 1/2 over root 3 over 2. So let's say 1/2 over root 3 over 2 equals 4 over x. So let's first figure out what this is. 1/2 times 2 over root 3, which is 1 over root 3. So now we say 1 over root 3 equals 4 over x. If we cross multiply, we get 4 root 3 equals x. So this side length is 4 root 3. Okay, so now moving on to this one. We have an angle here, 53 degrees. We also have the side opposite, and we have the hypotenuse. So opposite and hypotenuse is sine. So we're going to set up the trig ratio. Sine 53 equals 25 over x. Now, unfortunately, 53 degrees is not a special right triangle. So the only way that you're going to be able to figure out what sine 53 is with your calculator. So on a test, for example, a problem like this would have to be on the calculator part of the test. So if we want to solve for our unknown, we would just say x sine 53 equals 25. Divide both sides by sine 53. And so you get x equals 25 divided by sine 53. And if you want to plug that into your calculator, make sure when you plug that into your calculator that your calculator is in degree mode. If you go to the mode key on your calculator and arrow down, it's the third menu choice. Your calculator always defaults to radian mode, but you want to make sure it's going to be in degree mode, so you arrow over and put it in degree mode. The only time it matters what mode it's in is if you're pushing a sine, cosine, or tangent button on your calculator. If you're not pushing one of those three buttons, the mode does not matter at all. So just keep that in mind. But since we would be pushing the sine key here, you want to make sure your calculator is in degree mode. So if you do plug that into your calculator, you see that x would come to be 31.3 units of length.